Hello Year 11. I'd like to thank the overwhelming majority of you for engaging so effectively with this process. In such a difficult and unprecedented time in education, it's so important that we are engaging our minds as much as possible. To that end, I thought it was just useful for me to go through some of the common issues I'm finding amongst students on the MathsWatch work. And so I'm going to review a couple of questions looking at graph transformations, and I'm also going to look at a probability question. And then next week's work will look at honing your algebra skills. So, very briefly before I look at some specific questions, there are really 6 forms of graphical transformation that you need to consider. If we start with some function f of x, then I can do a number of things to that function. I can multiply the whole function by a factor a. I can multiply the x values in that function by a factor a. I can add a value a to that whole function. I can add a value a to the x values in that function. I can multiply the whole function by -1, or I can multiply every x value by -1. And these are the 6 transformations that you need to know. So if we begin at the top, if I'm multiplying by a factor, then I'm talking about enlargements. My first here, multiplying the whole function by a, is an enlargement. It's an enlargement in the y-axis of scale factor a. So that means if I have 2f of x, I'm multiplying all of my y values by 2. And we would say that my x-axis is invariant. That is, my x values do not change. That's particularly important in the MathsWatch tasks you've seen. F of ax is also an enlargement, but this time in the x-axis, and that's of scale factor 1 over a. So if I have f of 2x, I multiply all of my x values by 1 over 2, by a half. And equally I would say y-axis invariant for that transformation. F of x plus a is a translation. I'm adding a to all of my y values, that's what f of x is. And so it's a translation by the vector 0, a. That is, I move my entire graph up a. So f of x plus 2 would be moving every single data point up by 2. F of brackets x plus a is also a translation, but it's now in the x-axis, and it's by minus a, 0. And so, if I imagine, for example, I have f of brackets x minus 2, close brackets, then I would be moving every single coordinate on my graph 2 points to the right. That is, I'm adding 2 to my x-axis. Then I have minus f of x and an f of minus x, and these are reflections. Here I'm multiplying my y values, f of x, by -1. In other words, all of my y values that are positive become negative, and negative become positive. So this is a reflection in the x-axis, and conversely, this is a reflection in the y-axis. Now I sort of remember these in my head. I know that if I'm multiplying, I have an enlargement. If I'm adding, I have a translation. And if I have a negative sign in there, I have a reflection. And I just remember that y does what I would expect. So a translation of a if I'm adding a, an enlargement of scale factor a if I'm multiplying by a, and the x-axis does the opposite of what I expect. A scale factor of 1 over a if I multiply by a translation of minus a if I add a. And then my reflections are just approached in the way I have described. So I'm multiplying all my y values by -1, so think about what that does to each of my graphs. So I can use this now to approach some of the questions in MathsWatch. The first question that seems to cause people issues is this one. A sketch of the curve of the equation y is f of x, the vertex of the curve, which means the minimum point here is at 2 minus 3. Write down the coordinates of the vertex of the curve of the equation f of x plus 5. I look at my list, that's in the form f of x plus a, so that's a translation by 0, 5. In other words, every point on my graph is going to move upwards by 5. So my x value would remain unchanged, that's 2, but my y value would be -3 plus 5, 2. And so the coordinates of my vertex are 2, 2. Minus f of x is a reflection in the x-axis. I'm multiplying all my y values by -1. So my curve will look something like this. My drawing's not great. And my vertex, therefore, will have just been reflected in the x-axis. My drawing's terrible, actually. It's just been reflected in the x-axis. So, if my y value here is -3, when I reflect it, it's going to be 3 above the x-axis. So my equation will be 2, 3, or my coordinates, sorry, will be 2, 3. I can apply a similar approach to another question on the Maths Watch. The curve of that equation is translated by 2, 0. Select the equation of the translated curve. So that's moving to the right by 2. So that's f of x minus 2 then. So what that means is that I replace each of my x values here with x minus 2. So I have y is equal to x minus 2 all squared plus x minus 2 plus 2. I can simplify this. X squared minus 2x is minus 4x plus 4, and then plus x minus 2 plus 2. And collecting like terms, I have x squared, I have minus 4x plus x, which is minus 3x. I have plus 4 minus 2 plus 2, which is just plus 4. Oh, I see. And actually, I didn't need to bother doing any of that because the answers are given in my unexpanded form. But that's how you would approach a more complex question of this type. The third question I want to talk through is probability. I'm not really sure why this caused issues, but I think it's important that we cover it because I was asked about it a number of times, including from students who generally are doing pretty well in maths. The table below shows a 3-day rain forecast for Friday, Saturday and Sunday in Aberystwyth. And you're given there the probability of rain is 70% in each case. Work out the probability it will rain on all 3 days, and then the probability it will rain exactly 2 consecutive days. Now, if you can do this in your head, that's great. It would just be rain times rain times rain, so 0.7 times 0.7 times 0.7. So 0.7 times 0.7 times 0.7, which gives me 0.343. And then work out the probability it will rain on exactly 2 consecutive days. If you need a bit of help scaffolding this for yourselves, it's always worth drawing a probability diagram. It can rain on each of the 3 days, or it cannot rain on each of the 3 days. I've not drawn this as an amazing diagram, but you get my point here. So this is Friday, Saturday, Sunday, and it can either rain or not rain, 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 and then rain or not rain, rain or not rain. Now I don't need to fill all of this in. I want it will rain on exactly 2 consecutive days. So that's either the probability that it rains on Friday and Saturday, but not Sunday, because it's exactly 2 consecutive days, or it's the probability it rains on not Friday, but Saturday and Sunday. There are no other options. So I've got 2 branches that I care about then. I've got rain, rain, not rain, which you should be fine with being 0.7 times 0.7 times 0.3, or I've got not rain, rain, and then rain, which is 0.3 times 0.7 times 0.7. And so, I just need to add those 2 probabilities together. I have 0.7 times 0.7 times 0.3 plus 0.3 times 0.7 times 0.7, which is just 0.294. And so that's my final answer. So hopefully that shed a little bit of light, and I look forward to seeing your answers to this week's problems.